After studying this module, you shall be able to understand how philosophical debates guide and govern research and knowledge production. You will be able to learn about the historical emergence of the logical positivistic movement. You will be able to identify the influence of logical positivism in psychological research. You will also be able to evaluate the major philosophical tenets of logical positivism. You will be able to analyze the weakness inherent in the principles of logical positivism. Let us look at some of the introductory notes. One of the most influential schools of philosophy of science in the 20th century was logical positivism. This school of philosophy developed in Austria and Germany in the 1920s and was also known as logical empiricism. The development of logical positivism was influenced by the rapid changes taking place in physical science and mathematics. Thus, this view upheld the notion that scientific knowledge was the most important kind of factual information that was available, and all metaphysical doctrines were to be rejected as meaningless. Since science was believed to be the model for intellectual and social progress, logical positivists resorted to analyzing the structure of scientific knowledge and reasoning. The practice of logical positivism believes in two major sources of knowledge. One being logical reasoning, the other being empirical experience. The proponents of logical positivism included Moritz Schlick, founder of the Vienna Circle, Rudolf Carnap, Hans Reichenbach, founder of the Berlin Circle, Alfred Jules Ayer, Herbert Figel, Philipp Frank, Kurt Grelling, Hans Hahn, Carl Gustav Hempel, Viktor Kraft, Otto Neurath, and Frederick Wiesmann. Despite being influential, the movement was short-lived. Many philosophers and scientists today believe that logical positivism has left an indelible mark on the philosophy of science. This influence of logical positivism is particularly noticeable in the attention philosophers give to the analysis of scientific thought and to the integration of results from the technical research on formal logic and the theory of probability. To better understand these developments, let's revisit the movement. Let's go through the historical background. The philosophy of logical positivism did not emerge in isolation. The questions and the issues which had been raised by this circle of philosophers were no different from those raised previously at different times. This section focuses on the forces that influence the development of logical positivism to a great extent. Let us look at the classical empiricism. Logical positivism borrowed itself from the 18th century classical empiricism, which postulated that all knowledge can be gained only through the senses. This position was opposite of the rationalist position, which stated that knowledge can be gained through the use of reason. One of the key figures of classical empiricism was John Locke, 1632 to 1704. Locke proposed that everything is learned and nothing is innate. It is through experiencing and learning that the mind is furbished. The mind of a newborn child is, according to Locke, a tabula rasa, or an empty slate, and it is by experiencing the world through his or her senses that he or she develops ideas which become the source of all knowledge. Hence, the empiricist philosophers, therefore, strongly upheld that only sensory data could be treated as evidence, which is verifiable in nature, instead of the metaphysical propositions favored by the rationalists. Other empiricists like David Hume, 1711 to 1776, Thomas Hobbes, 1588 to 1679, and Francis Bacon, 1561 to 1626, also emphasized on the observable consequences of actions. Additionally, few American pragmatists like C.S. Peirce, 1839 to 1914, William James, 1842 to 1910, and John Dewey, 1859 to 1962, also served as inspirational influence for the logical positivists. Positivism. Logical positivism combined developments in empiricism and pragmatism with the existing positivist tradition, whose primary propagator was the French philosopher Auguste Comte. Comte's ideas influenced both sciences, natural as well as social. The positivist approach believed that the society functions in similar manner as the physical world, since the basic principles and general laws are applicable in both. In physics, the French mathematician as well as a philosopher Jules Henry Poincare (1854 to 1912) applied the positivist ideas so as to construct a mechanism for comprehending and measuring human sensations and perceptions in terms of basic physical concepts. Ernst Mach (1838 to 1916), an Austrian physicist, took a similar view. He proposed that the laws of physics were synonymous to the laws of all other sciences, including natural sciences, and were just a shorthand summary of the numerous relationships which exist between the experiences of different observers. Russell's mathematical logic. Bertrand Russell's mathematical logic exerted a great influence on logical positivism. Much of Russell's work was concerned with the desires for perfect clarity and absolute certainty, resting on the belief that analysis can be pursued down to certain indivisible elements, which are in some way incorrigible and hence justify the intellectual edifice constructed from them. For this purpose, he distinguished knowledge by acquaintance, which is indubitable, from knowledge by description, which may be in error. Examples of knowledge by acquaintance are sense data and the contents of our own memory. Borrowing from Russell, logical positivists not only adopted the thesis that all knowledge must be based on sense experience, but were driven by the same motive of certainty and perfect clarity. Wittgenstein's Tractatus was a text proposed by Ludwig Wittgenstein. It was of great importance for the positivists. The school of thought believed that the basic building blocks of reality are objects, simple and unanalyzable pieces of information, which combine together to exist in a context forming the state of affairs. It has further focused on linguistic reforms by using modern logic and has also drawn attention to deducing a theoretically principled distinction between intelligible and nonsensical discourse. Wittgenstein's influence is further evident in certain formulations of the verification principle. Wittgenstein also influenced interpretation of probability by the logical positivists. Let us look at the Vienna Circle. The Vienna Circle was a group of scientifically trained philosophers and philosophically interested scientists led by Moritz Schlick. These professionals often met on Thursday evenings every week for discussing the problems regarding the philosophical dimension of scientific disciplines. The meetings began during the academic term in the year 1924 and continued till 1936. These thinkers were greatly influenced by recent developments in science, particularly Einstein's physics, mathematical logic, and philosophy of language, and sought to synthesize these new ideas to institute a new philosophy. These group of philosophers were against German idealism in particular. Hegel and Heidegger, who derived much of their ideas from German idealism. They found their philosophies too abstruse and unclear. The Vienna Circle placed a high premium on reason, clarity, and precision of language. They wanted to dispel mysticism, romanticism, and nationalism. They also rejected the need for interpretation. Schlick, who was the leader of the distinguished group, had been appointed to Mascher's old chair in philosophy of the inductive sciences at the University of Vienna in 1922. Apart from him, the group also involved participation of Hans Hahn, the mathematician, the social scientist Otto Neurath and his wife Olga Hahn-Neurath, who was a mathematician. In addition, the philosopher Viktor Kraft was also a member of the group, along with Theodor Radkovic and Gustav Bergman, both of whom were mathematicians, and lastly, Rudolf Carnap, a philosopher as well as a logician who joined the circle only in 1926. After its formative phase, the circle went public in 1928 and 1929. It is then that the Vienna Circle became popular amongst the population of intellects and began to play a prominent role in the academic as well as the public sphere. Throughout the early and mid-1930s, the Circle held numerous conferences and presented various publications which helped it to establish an international profile. In 1930, the Circle, together with the Berlin Society, took over the journal Anländer Philosophie and restarted it under the name of Erkenntnis, which was co-edited by Carnap and Reichenbach. Let us look at some of the themes of logical positivism. Although the varied members who were a part of the Vienna Circle disagreed and had issues of dispute, there were a few positions they agreed upon as well. These being, first, they advocated reliance on experience as a guide to knowledge. They postulated that all forms of knowledge, except for the analytic truths of mathematics and logic, should be derived from experience, thereby making it a philosophy of radical empiricism. Second, they rejected metaphysical claims, that is, the claims that could not be verified by appealing to the given facts and evidence, literally the data, experience. In this sense, they were positivistic in their approach. Third, they hailed the methods of physics as truly scientific and the only way to true knowledge. Thus, they propagated the use of methods like observation, experimentation that were used by physicists to learn more about the world. Finally, they emphasized on the importance of logical constructions, since these constructions relate the basic forms of data in the form of sensations, measurements, etc., to the higher order objects which are ingrained in scientific theories like atoms, waves, energy, etc. The main philosophical tenets of logical positivism are the verifiability principle. One of the chief tenets of logical positivism was the verifiability principle. According to this principle, the meaning of a sentence depends upon its method of verification. They ask the question, how do words get meaning? Whereas Plato conceived of a realm of ideal forms from which meaning is received. The logical positivists held the view that meaning of a sentence is the means by which we verify it. In other words, its meaning encompasses the measurements one would make to determine its truth or falsity. As Schlick observed, the criterion of the truth or falsity of the proposition then lies in the fact that under definite conditions given in the definition, certain data are present or not present. If this is determined, then everything asserted by the proposition is determined and I know its meaning. For instance, let us consider the proposition which states that temperature of a certain volume of water is 90 degrees Celsius. What is the meaning of this statement? The answer from a logical positivist orientation would be that if a thermometer is immersed in the water, then the reading will show 90 degrees Celsius. Still, reading a thermometer will provide a vague and incomplete description. For a more precise description, the Celsius thermometer should be immersed in the water, the reading should be allowed to stabilize, and then the observation should be made, which may indicate that the reading is opposite the 90 mark. This is still somewhat far from sense data. However, so a further explication might be when the meniscus of the mercury column stops moving, it is closer to the line marked 90 than to the lines marked 89 or 91. In general, it can be said that all meaningful statements of fact are measurable, and these measurements are eventually dependent on one's perception, such as judging which mark on a dial is the closest to a pointer. As can be easily inferred from the above example, that for a logical positivist, any statements that are not verifiable are not meaningful, which implies a rejection of all metaphysics. Indeed, they dispelled the need for metaphysics and focused on what was available for observation. Let us look at some sources of knowledge. According to logical positivism, there are two main sources of knowledge. One being logical reasoning and the other being empirical experience. The former is analytic a priori, while the latter is synthetic a posteriori. The fundamental thesis of logical positivism consisted in denying the possibility of synthetic a priori knowledge. To better understand the fundamental thesis, let us review analytic and synthetic statements. Consider the following examples. Statement 1. All bachelors are unmarried men. Statement 2. Many bachelors are doctors. The first statement we know is true by virtue of the definition of the terms. We know that bachelors mean unmarried men. Here, the predictable adds nothing to the subject. Such statements whose truths seem to be knowable by knowing the meanings of the constituent words are analytic statements. The truth or the falsity of the second statement is dependent on empirical verification. Notice here that the predicate "are doctors" adds something to the subject "many bachelors." Such statements whose truth is knowable by both knowing the meanings of the words and something about the world are synthetic statements. A priori and a posteriori. A priori is Latin for "from the earlier," and Kant used it to refer to these objects of our knowledge that are known outside of our experience. In other words, their justification does not rely on experience. Example, all unicorns have horns. A posteriori is Latin from the later and refers to those aspects of our knowledge that are known through experience. Example, all crows are black. These distinctions have been discussed by Kant in the Critique of Pure Reason 1781. Kant believed that synthetic a priori can exist, that is to say, that something whose justification does not rely on experience but which can be empirically verified. For example, the axiom 8 plus 5 is equal to 13, according to Kant, is an a priori but at the same time synthetic, since it can be verified empirically, and because the concept of 13, the predicate, is not contained in the concepts of 8 and 5, the subject. The statement is synthetic. However, with the developments in the logic by Frege and Russell, indicated that statements in arithmetic can be considered analytic a priori rather than synthetic a priori, and created a distinction between logical analysis and empirical investigation. Influenced by the work of Russell and Frege, the logical positivists denied the possibility of synthetic a priori statements. Let us look at reductionism and the unity of science. The logical positivists heralded physics as the highest science and believed that all knowledge could be reformulated in terms of the language of physics. In other words, propositions expressed in biological terms could be restated in physical terms. In this manner, all knowledge could be reduced to physics. The thesis of physicalism emphasized that the language of physics is a universal language of science. That is to say, that every language of any subdomain of science can be equivalently translated into the physical language. From this, it follows that science is a unitary system within which there are no fundamentally diverse object domains and consequently no gulf, for example, between natural and psychological sciences. This is the thesis of the unity of science. The proponents of logical positivism were not able to follow this principle, but their belief to explain phenomena in physical terms and to accept the methodology of physics as the standard of real science is still widely accepted in the scientific field. Let us now look at some of the limitations or the criticisms that have been leveled at the logical positivism. By the end of 1930s, the logical positivist movement had started to break down and was drawing towards its end. However, the ideas and methods of logical positivism continue to this day in various disciplines. The reasons for the breakdown of logical positivism can be grouped into two categories. One, its internal weakness, and two, the external criticism. Let us look at the internal weakness. One of the foremost criticisms was that logical positivism rendered certain forms of languages like poetry, ethics, and theology meaningless, for they are untestable. Even though this problem did not bother them, it created contradictions and inconsistencies for their model. Consider the following example. Water is blue and God is good is testable under the rules of logic. If A is false, then A and B must be false. While part of this statement is meaningless, another part is verifiable, but it makes for a tricky position to occupy. They tried but failed to solve this contradiction. Another point of criticism for logical positivists was the status of verifiability principle. The verifiability principle could not be classified as an analytic statement, which meant that it had to be synthetic. However, the logical positivists were confronted with the problem of reflexivity. How could the theory of verifiability be verified? Even the distinctions that the logical positivists based their theory on were not empirically testable. For instance, one may ask whether there is a scientific way to make sense of the analytic-synthetic distinction. In fact, the distinction between analytic and synthetic propositions can collapse with the revision of the analytic statements in the light of new experiences. For example, parallel lines do not intersect is an analytic statement. However, with the discovery of black holes, we know that space warps make it possible for parallel lines to intersect. A final problem with the verifiability principle was to do with its application itself. The application of this principle would suggest that no scientific law is meaningful. For example, it can be verified that Socrates is mortal, that Plato is mortal, and that Aristotle is mortal. However, it is not possible to verify the statement that all people are mortal. This is because an infinite number of cases would have to be observed in order to verify this position. Scientific laws are applicable to an infinite number of situations, and since it is not possible to verify innumerable cases, they remain strictly unverifiable. Let us now look at the external criticism. Quine, 1908 to 2000, in his seminal paper, The Two Dogmas of Empiricism, 1951, stated that testing and meaning are holistic in nature. That is to say, when testing one idea or hypothesis, we test other related ideas as well as any other time we get a result that is not anticipated. The problem may lie with one of the assumed or related ideas and not necessarily with the hypothesis being tested. If testing an idea means testing other statements associated with it, then we also subject the analytic statements to testing, which contradicts the very supposition that analytic statements are immune from testing. Karl Popper, 1902 to 1994, like the logical positivists, was concerned with the problem of demarcation. He said that the question of meaning were of little or no relative importance. Instead, a demarcation was required in the theories and the methods of testing them. In other words, Popper proposed the distinction between science and pseudoscience on the basis of falsifiability. Popper believed that scientific theories could not be proved to be true because of the theory of induction. He thought that the logical positivists were on an incorrect path and that the thing that marked out science was its potential to be falsified. While it is the case that no finite number of observations can ever prove the truth of a universal scientific theory, logically only one case is required to contradict a theory's universal assertion in order for it to be falsifiable or refuted. What is distinctive about the scientific theories is that not only that they can be proved true, but they are testable and therefore falsifiable. Among others, Thomas Kuhn's 1922-1996 celebrated work, The Structure of Scientific Revolutions in 1962, gave a final blow to logical positivism by attacking the premise that observation is a secure base for scientific knowledge. He argued that observations are influenced by the very paradigm the observer works with and that it cannot decide between competing theories. Elaborating Hansen's concept of theory of ladenness, Kuhn stated that observers do not make identical observations because what they see depends on what they know or what they believe. Consequently, all knowledge is based on paradigms which limit the field of investigation by restricting questions and answers and that condition expectations. Logical positivism and its connect with psychology. Much of the 19th century research in psychology was dominated by logical positivism. The rise of behaviorism, with the emphasis on observable behavior, scientific experimentation and accurate measurement, is a testimony to the influence of logical positivism. Though the first behaviorist manifesto, released by Watson in 1913, precedes the Vienna Circle, B.F. Skinner, who is one of the principal advocates of behaviorism, traced his ideas to Mark, Poincare and Comte. These people are also considered the forerunners of the logical positivists. Clearly, behaviorism and logical positivism share ideas which were prevalent or in the air at that time. Logical positivism believed in theorizing while maintaining objectivity and thus led to the emergence of more complex forms of behaviorism. S.S. Stevens, a prominent American psychologist, tried to formulate a psychology which followed the diktats of logical positivism in an attempt to bring it on par with physics. With the growth of logical positivism, operationism grew rapidly and was established within the discipline of psychology immediately. Operational definitions began to be used for converting theoretical terms such as drive, learning, anxiety, and intelligence into empirical events. These terms were thus stripped of their metaphysical connotations by being operationally defined. This approach was in line with psychology's new emphasis on the observable behavior. For example, learning could be operationally defined as being able to make n number of successive correct turns in a T-maze, and anxiety and intelligence could be operationally defined as scores on their respective tests. Such definitions were entirely based on publicly observable behavior. They had no excess mentalistic meaning. Most psychologists soon agreed with the logical positivists that unless a concept can be operationally defined, it is scientifically meaningless. Neo-behaviorism resulted when behaviorism was combined with logical positivism. Logical positivism paved the way for various forms of behaviorism: objectivity in data collection, an agreement about specific modes of objectivism, and about the theoretical implications of objective data. Now let's summarize. Logical positivism is a school of philosophy born in 1920s in Austria and Germany, when a group of scientists, philosophers and mathematicians came together to formulate a science which was certain and clear. Its main assertion was that only statements that could be verified empirically were genuine. Logical positivists denied the soundness of metaphysics and traditional philosophy and went on to assert that many philosophical problems were indeed meaningless. According to logical positivism, there are only two sources of knowledge: logical reasoning and the other one being empirical experience. The verifiability principle was the cornerstone of their philosophy, along with the goals of reductionism and unification of all sciences. The inherent contradictions in the verifiability principle and the critique of their assumptions by other philosophers led to the fall of logical positivism. Logical positivism influenced all disciplines, including psychology. The rise of behaviorism and logical positivism boosted new forms of research and theorization in the discipline of psychology. The impact of logical positivism continues to exist even till today. A number of their ideas have been assimilated by other philosophies or research methodologies.